Welcome to the 7.2 notes. Today we are going to learn how to simplify, multiply, and divide rational expressions. First things first, what is a rational expression? A rational expression is a fraction made up of two polynomials. So kind of take a look at some of the examples on this page. You're going to have like x's and exponents and constants on the top and the bottom. So multiple terms on the numerator, multiple terms on the denominator, and pretty much your goal is to factor in hopes that you will have a factor that is on the top and the bottom, so that then you can simplify by crossing out common factors. A factor is something that multiplies to something else. That's why we have to factor it first and then cross out common factors. There are going to be some monomials in which we need to subtract exponents and divide the coefficients. For example, the first problem. If I split this problem in half and we look at the left side and the right side, 20 and 14. 20 is 2 times 10, and 14 is 2 times 7. 2 is a factor of both of them that gets to cross out, so I have 10 over 7 left. Then I subtract my exponents. X to the 6th over x squared. 6 minus 2 is 4. And that's the answer to that one. Now that one's a little bit easier because it only has one term on top and one term on bottom. It's missing the addition and subtraction that most of the other problems have. I just needed to bring it up to let you realize that if there's no addition or subtraction, those rules still exist like they did before. But most of what we're going to be doing is slightly trickier than that. Because what you want to do is try and factor the numerator and the denominator. So before I go any further, go ahead and flip to the back side with me really quick. I have made this factoring flowchart for you where, first of all, you have got to do your greatest common factor first if there is one. You always have to look for that first. Then, if you only have, if you only have two terms, two things, then either it's difference of squares, like this one, or you're done. Underneath done, I'm going to write GCF only, because this is assuming we've already looked for the GCF. If you think you're done, you need to make sure you actually did a greatest common factor first. Otherwise, maybe it actually isn't factorable. If there are three terms, you need to see if there's a number in front of x squared. If there isn't one, if it's just 1x squared, you need to find two numbers that multiply to the last and add to the middle. And then you just write it in two sets of parentheses like this. 7 and negative 2 multiply to negative 14 and add to 5. If there is a number in front of x squared, though, you have to split up the middle like this. You're looking for two numbers that still add to the middle like they did before, but they have to multiply to the first times the last. And if there are four terms, then you're just going to use what we call grouping. Here's an example if it helps you. X cubed plus 4x squared minus 3x minus 12. You would split this in the middle, kind of where I have the line. I did that on purpose. You can take x squared out of these two, leaving you with x plus 4. And you can divide negative 3 and negative 12 by negative 3, leaving you with x plus 4. the whole parentheses should match, which it does. And then the two numbers that are on the outside, x squared minus 3, go in the other parentheses, like so. So there's an example if you need an extra one over there. And those are your types of factoring: 2 terms, 3 terms, and 4 terms. I'm also going to go through them as I see them in each problem. Just know that I put this factoring flowchart back here for you. There are also some rules and tips at the bottom. Those aren't going to make as much sense if we haven't done the notes yet. So kind of keep those in your back pocket for a second and flip back to the front side with me. Okay, and then the next one, number 2, I'm going to go ahead and factor first. On the top part, I only have 2 things, and it's not difference of squares, so I need to make sure I've checked for a greatest common factor. I can divide 6 and 36 by 6, leaving me with k minus 6 inside. The whole point of that was that you'll notice that the bottom part is already k minus 6 all on its own. So I have a k minus 6 on top and a k minus 6 on bottom. The whole factor matches, so that whole thing gets to cancel out. And my answer, guys, is just 6. How cool is that? That's the whole goal today. Get something on top that's also on bottom and cross it out. Period. That's going to happen on every problem. If it doesn't, you've done something wrong. Next one. Top part, I only have 2 things, and it is a difference of squares. Because p squared is a perfect square, 49 is a perfect square, and they're being subtracted. So what I do is I do the square root of them, which is p and 7, in 2 parentheses, one with a plus, one with a minus, and it's factored. You should know that one by now. We've done it a lot. On the bottom, you'll notice that things are a little out of order. This is really technically negative p plus 7. And before I go any further with this one, I want to take a pause, come back over here to the left. Number 3 is our special case. If the variable is after the constant, like it just was, like this one is negative x plus 8, then you need to use a greatest common factor of negative 1. Or something different if you need to. What that does is if you take out a negative 1, negative x divided by negative 1 is positive x, and 8 divided by negative 1 is negative 8. So it sort of allows you to flip the signs around so that the x is now positive. If you don't know how to do this, then you'll miss common factors that otherwise would have canceled out. All right, now what that helps us with, let's do the next one down below it. This would be negative 3x minus 12. You can divide both of those by negative 3, which then leaves you with x plus 4. Okay, so flip it around. If it's negative in front, take that negative out. You're good to go. So what that means over here on the problem we were working on is I take out that negative, and instead of negative p plus 7, it'll be positive p minus 7. And now that matches the p minus 7 that's also on top. So they cancel out, and I get p plus 7 over negative 1. Go ahead and actually divide them by negative 1. That'll be negative p minus 7 is your final answer. Just because if you can get rid of the fraction, do it. We don't like fractions, so why leave your answer as 1 if you don't have to? All right, next row. Things are getting a little more complicated on this. On the top, I noticed that they both have an A. So part of my greatest common factor up there is going to be an A. The other part is that I can divide 12 and 3 by 3. Which leaves me with 12 divided by 3 is 4. I had a cubed, but I took out an a, so now it's only a squared. Negative 3 divided by 3 is negative 1. A was there, but we took one outside, so now there's no a left with that. Then, before I even move to the bottom, I have an a squared inside the parentheses, and that almost always means I can keep moving. Those are both perfect squares. 4 and 1 are both perfect squares. So what that means is I keep the 3a out front, but I go ahead and do the square root. The square root of 4a squared is 2a, and the square root of 1 is 1. Plus 1, minus 1. Now I can focus on the bottom part because the top part's all the way done. On the bottom part, 12 and 6. 6 goes into both of those. They both have an a, and actually you'll notice that there's actually enough space for me to take out a squared because they both have an exponent of 2 or more. So divide the numbers by 2 and take away 2 from the exponent. So a cubed is now just a, and the a squared at the end just isn't there at all now because it's all out front. Then that's the bottom part. 6a squared, 2a plus 1. What can I cross out that's on top and bottom? 2a plus 1. And the a on the top will cross out one of the a's from the squared. So it'll just be a on the bottom like that. And what's 6 divided by 3? 2. Just realize that 2 stays down here at the bottom since that's where the 6 was. So all I have left is 2a plus 1, or 2a minus 1 on top, 2, and an a on the bottom. And that's it. So you've got to keep looking for the most possible things you can cross out. Next problem. I have 3 things on the top, so I need to look out front. There's a number there, but it's 2, and I can divide that whole thing by 2. Then on the bottom, actually I'll finish the top part first, because there's 3 things, r squared, negative r, and negative 20. I need to figure out what multiplies to negative 20 and adds to negative 1. Negative 5 and positive 4. So r minus 5 and r plus 4. Negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. Done. Bottom part. 8 and 32 can both be divided by 8, which leaves me with r plus 4. There's no squared or anything on the inside, so that one's just done. 8r plus 4. So I'm just copying it down again so I can see what crosses out. The r plus 4s. And I know that 8 divided by 2 is 4, but the 8's on the bottom, so the 4 will go on the bottom. So all I have left is r minus 5 on the top and 4 on the bottom. Next problem. I've got a negative 5w at the end, so I've got to rewrite it at the beginning. The 45 is actually positive. So now it's in the correct order. What's my greatest common factor? If you said 5, you're really close. It's actually negative 5, because you don't want to start any parentheses off with a negative inside. So that leaves me with w minus 9. Really important to realize that that's negative 5, otherwise it won't match later like you want it to. Okay, I've got some work to do on the bottom because that 3 in front cannot be divided. 28 does not divide by 3. So this is one where you have to split the middle because of that 3 out front. So to split the middle, you figure out what multiplies to 3 times 9, which is 27. 1 times 27, 3 times 9. We need it to add to negative 28. So what we're going to do is come over here and we're going to write the 3w squared and the plus 9. And in the middle, instead of negative 28w, we're going to write negative 1w minus 27w. Because negative 1 and negative 27 multiply to 27 and add to negative 28 in the middle. And then you split it down the middle like this. I can divide the first two by w. Nothing goes into 3 and 1. That leaves me with 3w minus 1. Negative 27 and 9 can both be divided by 9. But since there's a negative in front, you need to make that negative 9. Negative 27 divided by negative 9 is positive 3w. Negative 9 divided by negative 9 is negative 1. So you've got your two 3w minus 1s. That's the first factor of the denominator. The other factor is w minus 9, the parts that we put out front. Then on top, you leave what you already had and look for something that crosses out because you're done factoring. W minus 9, and that's it. This is your answer. I'll rewrite it down here if it helps you to see it. But you don't have to rewrite it if you already have it listed in your work. Okay. The next problem is going to start getting into some multiplication. So what we're going to do is come over here to the left, and I'm going to give you an example. 2/4 times 5/6. What you are allowed to do is multiply the top two and the bottom two. 2 times 5 is 10. 4 times 6 is 24. Then I would divide by 2 because I need to simplify. And 5/12 would be my final answer. That's it. When you're multiplying fractions, you just multiply the top two, multiply the bottom two. But what you want to do is factor all of them first, and then multiply the numerators together and multiply the denominators together. That looks a lot different than you might think, though, on some of the later problems, so I'll kind of keep re-explaining how that part works. So I can't factor the first problem, the next problem, because there's no pluses or minuses, so I just go ahead and multiply. 6 times 10 is 60. X to the third and x to the second make x to the fifth, because you add those exponents. And x cubed and y cubed and y to the fourth makes y to the seventh. Like that. Bottom. 2 times 18 is 36. X squared is the only x down there, so it's just still x squared. Y squared and y squared makes y to the fourth. So it's now one fraction instead of two. And we're going to do the same thing we did on like the first problem, where I'm going to split it up. Look at just the regular numbers, the coefficients, look at the x's, then look at the y's. Take each part as its own piece or it'll get a little bit too confusing. So 60 divided by 36. I can't divide 60 by 36, but I can divide them both by 12. Because 60 is 12 times 5, and 36 is 12 times 3. So the 12s cancel, and I get 5 over 3. And then I subtract my exponents. 5 minus 2 is x cubed. 7 minus 4 is y cubed. It only goes to the bottom if it was a negative exponent. That's why they're both on the top. Done. Now it does get a little bit different for the next one, because I actually can factor. And I have set up these problems to leave you enough space above and below it on purpose. I'm going to factor each one above it if it's a numerator or below it if it's a denominator, like this. 4x squared and negative 4x can both be divided by 4x, leaving you with x minus 1. On the right, I have 3 terms, so I need to find what multiplies to negative 6 and adds to 1 in the middle. Well, that'll be 3 and negative 2. So x plus 3, x minus 2. So when I go to multiply these together, all that does is it becomes 4x, x minus 1, x plus 3, x minus 2, all together in one fraction. In fact, you don't even have to write it over there to the side if you realize this is all just going to become one fraction. On the bottom left, I notice I can divide all of those by 2. And then I need 2 numbers that multiply to negative 3 and add to 2. That's x plus 3, x minus 1. The other denominator, I notice I can divide them both by 4. And they both have an x, which leaves me with x plus 2. So everything I have on the bottom part is 2, x plus 3, x minus 1, 4x, x plus 2. And now I've got everything factored and put together in one fraction. Cancel anything that's on top and bottom. I see an x minus 1 on top and bottom. I see an x plus 3 on top and bottom. I see 4x on top and bottom. And that's it. The 2's are close, but one of them is minus 2 and the other one's plus 2. So I have x minus 2 left on top and 2 x plus 2 on the bottom. So be careful. Make sure you carefully look at what you have left to make sure you're not accidentally overlooking something. And that's it. The main difference between multiplying and simplifying is more factoring. Otherwise, they work pretty much the same. Okay, then for division. If you notice that there is division right here, you have to flip the last fraction, and then you're going to multiply instead of divide. We don't really divide fractions because things get pretty messy. In fact, here is my rhyme. Dividing fractions is easy as pie. Flip the last and multiply. Before I get into that one over there on the right, here's an example with just numbers. 2/3 divided by 5/6 is the same thing as 2/3 times 6/5. So you just flip the second fraction and then you can multiply it instead of divide. That's what dividing by a fraction does, is it makes it the reciprocal and flips it. So we are going to factor the top part. I can take out 2 and an a squared, which leaves me with a minus 6. Then I'm not actually going to factor the top right and put it on the top right. This one is going to get flipped to the top. So what 2 numbers multiply to 15 and add to negative 8? Negative 3, negative 5. So I have 2a squared, a minus 6, a minus 3, a minus 5 on the top. And actually, I'm going to move that up just a little bit. Okay, on the bottom, I need two numbers that multiply to negative 12, add to negative 4, which is a minus 6, a plus 2. And then on the right side, it's actually the top one being flipped to the bottom. 24 and 8 can both be divided by 8, and they both have an a squared, which leaves me with 3 minus a. But I don't want to leave it like that because otherwise I won't be able to find its match. So what I'm going to do is switch it to a minus 3. But as I do that, I'm switching the signs because the a was negative and the 3 was positive. So I have to change the thing out front to negative 8a squared because it was out of order. So I have a minus 6, a plus 2, negative 8a squared, and a minus 3 on the bottom. Start canceling out anything that's on top and bottom. A minus 6, a minus 3, which I wouldn't have found if I hadn't fixed the order, and a squared. Then I know that 8 divided by 2 is 4, so I'm going to cross out the 2 and change the 8 to a 4. So on top, I have the a minus 5 left. And on bottom, I have a plus 2 with a negative 4. That's it. Last one, same idea. I see division, so I'm going to have to flip these two across. Once you know to do that, it's exactly the same thing as multiplying. The 10 on top just stays on top. Then I need two numbers that multiply to negative 6 and add to 1, which I've already done right here in this problem. So I'm going to just kind of steal that. It's 3 and negative 2. So I have 10, x plus 3, and x minus 2 on the top. Those are my numerators put together. On the bottom, I can take out a 4 from this one, leaving me with x minus 2. And the top part that's now flipping to the bottom, I can divide by 2x, and I have x plus 3 left. Okay, again, make sure you're looking at it flipped a little bit. So I have 4, x minus 2, 2x, x plus 3. What can I cancel out? X minus 2's, x plus 3's. So essentially I have 10, and then that 4 times 2x makes 8x on the bottom. Is there anything I can divide 10 and 8 by? 2. So my final answer is 5 over 4x.